right, so I'm going to do something with you guys, and I assigned homework for this, for you to kind of go through this. I'm recording it so that you can go back and look at the actual video and see lecture again. But I'm going to go through the whole matrix stuff with you because that's the next step. 7.1, 2, and 3 are all about matrix algebra and using them to solve differential equations. That's why I thought it was weird. Like, why do we teach you some other way and then teach you this way when this way is the way, the whole reason for it? It seems bizarre. But I told you at the beginning, the first day of class, this is the most important equation that you could possibly have. And a few of you looked at me and said, how could that possibly be the most important equation? Close laptops. How could that be the most important equation? Solution's fairly straightforward. X of t is equal to x0 e to the at. Well, in mathematics, what we want to do is we always want to generalize things. So if you think about your courses that you've had, I think everybody in here has had linear algebra, or they're taking linear algebra. The whole idea of linear algebra is you're trying to do algebra with boxes of numbers and vectors. That the same way you kind of did things with real numbers. That's the whole point of that class. It doesn't feel like it when you're going through it, but that is actually what we're trying to do. Here, now if I have this, what about, I have a vector here, this, and I have, so this is a prime here, and I have this thing here, belongs to Rn now. Let's suppose I have a system of n differential equations. So this guy here is an n by n matrix. We call that the coefficient matrix. I think on the WPR I called it that. So it kind of looks like that thing above, exactly the same way. So as a mathematician, I would want to say I can write down the solution. The solution should look kind of the same way. You'll see why I'm writing it this way. You'd like to do that. Just like some students want to divide by matrices. You want to do that, but you can't because you lost the commutative law. Don't do that if you're in linear algebra now. It makes instructors want to drink alcohol. Okay, so, well, if I write something like this, and that's a matrix up there, any thoughts? That's right, that's pretty weird. So, what the heck does that mean? Exponentiating a matrix is kind of weird. And I put things in a certain order because I do know what it means. So the t is on the outside, it's a scalar, it's time. And the vector is, instead of the x0 being on this side, I put the x0 on that side. Well, what this e to the ta is, it's this time. What is that? It is. It's the power series expansion for E. And I can certainly take matrices and square them. I know how to do that. In fact, if you have integers inside the matrix, it's got to stop. It can't keep changing numbers after a while. So you can actually prove that. That'd be a nice proof for your linear algebra class. That's what that means. That's I, yeah, the matrix I, because so this guy here is a matrix. It's actually this thing expanded. That's what this is. And then you can ask yourself, well, how would I do that? That would be crazy to do that. I'm going to show you in a second how to do that. And if this was an n by n matrix and this is an n by 1 vector, the multiplication has to make sense. If I had put the vector over here, the multiplication wouldn't make sense. right? That's 101 first day of linear algebra. You're taught how to multiply matrices, and then maybe your instructor gave you a board problem of which of these can you multiply and which of them you can't, right? So that this is n by 1, and this is n by n, and the matrix multiplication has to make sense. And after you do that matrix multiplication, like expand the series, figure out what that is, do the matrix multiplication, then the answer is going to be an n by 1, which it should be, because each component has a solution. That's pretty cool. If you think this is really cool, you're in the right field. I've noticed something. If you like sequence in the series when you're taking calculus, and you're like, this is like the best thing in the world, and you look around like no one else feels that way in the class but me, you're on your way to being a math PhD. Almost every math PhD loves the sequence in the series section. I knew I was different. That's when I knew I was different. Okay, so let's keep going with this. Let's take this even further. If it makes you feel better, think of the matrix as being 2 by 2. So that you can actually see something instead of like 10 by 10. It's kind of like in linear algebra, you get 2 by 2s all the time, and then sometimes you get a 3 by 3. And you think, well, there's nothing beyond that. And then you do research and you realize you have a 100 by 100 matrix. Right. So from linear algebra, you have one of the most important theorems. I'm going to put two quotes. If you remember from linear algebra, you guys are not at who's in linear algebra right now? Okay, you're not there yet. This is going to be like, you're going to get there and go, I've seen this stuff. So there's something called eigenvalues, which you learned about in Jedi Math or MA 103, but it's really the eigenvectors that really matter. So if you have two eigenvectors, in linearly independent eigenvectors, because any multiple of an eigenvector is another eigenvector, and any linear combination of vectors are going to be another eigenvector. You can prove that actually. If I was teaching linear algebra, I'd give you that to prove. But if you have two independent eigenvectors, then what's true is A is what we call diagonalizable.
We're doing this.
That's awesome.
So Dr. Blair.
Right? So you might ask yourself, well, who cares? Well, this actually makes things a lot easier. It makes that calculating that Taylor series pretty easy. So I'm actually going to give you an in-class assignment to work with a little bit of eigenvalues and eigenvectors. When I show you script for Mathematica, I learned Mathematica in 1991. So I'm probably using my old stuff. I need it to work though. I don't care if there's a fancier way to do it. If you want some fancier way to do it, just wait.
Do today or next week? Or on Friday?
We'll do it on Friday. You can get done through it Friday. It's not that hard.
I should probably practice mine by hand.
No, don't do it by hand.
Oh.
I was going to do it by hand. No, don't.